Okay, now take the screenshot. These are the steps. So that would be like in paragraphs, okay? That is very confusing. So I think to be like here, mathematical form steps. Are you done?
Yes. Yes.
So when you work in your company, or even when I give you the assignment, even if it were in the exam, then you have only the given information. That would be secondary data. You will have only this. The rest you are on your own. So you pay attention, listen, okay? We are going to do the forecast for this company with 16 sales data. So we have to go through 4 steps, okay? This is the first part. As I said just now, when we forecast the sales, there are 2 main parts. The first part is to find the seasonal index, and after that, changing these here available secondary data to be deseasonalized sales data. That is the first part. And second part will be using different forecasting methods, and we will estimate the sales for the next period. Now we are going to do the first part, that is finding the seasonal index and statistic data. Okay? Step 1. Find the 4-year quarterly average for each quarter. We have to find the 4-year quarterly average. 4-year, because in this example, we are using 4-year sales data. In my company, if I have 7-year sales data, that would be 7 years here, 1, 2, 3, 4, 5, 6, 7, right? In your company, you have 20-year sales data, 1 to 20. You understood, okay? So here in this case, 4-year sales data, because there are only 4-year sales available. All right. Quarter by quarter. Okay. In a year, we have 4 quarters. So 4-year quarterly average, that means that when you look at this table, you will look at it horizontally. Year 1, 2, 3, 4. So year 1, quarter 1, year 2, quarter 1, year 3, quarter 1, year 4, quarter 1. You find the average, so you divide by 4. This 4 here, that is the number of the years. Don't get confused with number of quarters. Don't get confused. Number of year here. Okay? So if I use like 7-year sales data, divide by 7. If you have 20-year sales data, you divide by 20. So that is here step number 1. Can you follow?
Yes.
I think I'll let you take the screenshot first. Take the screenshot of this one. Done? This slide is a summary of all 4 steps. Okay? Are you done with this?
Yes.
Screenshot?
Yes.
Yes. Yes.
All right, so when we do step 1, finding the 4-year quarterly average for each quarter. I'm showing you this is for quarter 1, right? But when we look at the number of quarters, in 1 year, there are 4 quarters. So you take the note, okay? Step 1, you do it for quarter 1 to quarter 4. That means that you do it for calculation. quarter 1, quarter 2, quarter 3, and quarter 4. Okay, so for quarter 2, then here, see that? Quarter 3, the same thing, and quarter 4. So from step 1, then now you get this table, and not the table, this column. Okay, so this is a column. We call that a 4-year quarterly average. So the averages are here 1, 2, 3, and 4. Okay, step 1. Then now come to step 2. Step 2 is to find the mean of all the quarters, overall mean. So to find the overall mean of all the quarters, how many quarters we have here? Starting from year 1, quarter 1 until year 4, quarter 4, we have 16 sales data. So this is the total here, okay? And we find the average divided by 16. 16 means 4 years multiplied by 4 quarters, okay? So this is the average. Oh, wait a minute. Step 2. Step 2 is supposed to be here. Sorry guys, take the screenshot again. Step 2 is supposed to be here. Get it? So now when we come to step 2, starting from year 1, quarter 1, 49, until year 4, quarter 4, divide by 16 period, this is the overall mean. We do it only one time because we are finding the overall mean of all 16 quarters, only one time. All right, so we get it here already, step 2, 79.25, that is the overall mean, okay, of the 16 data. Then now let's go to step number 3. Step 3 is finding the seasonal index. To find seasonal index, we have step 1 divided by step 2, then we get step 3. Okay, so we have the 4-year quarterly average, quarter by quarter, and we have the total overall mean. So the average of quarter by quarter, we divide by the total overall mean, we get the seasonal index. So here is the example, right? From step 1, we get 58. So here, step 2, 79.25. So we get the seasonal index for quarter 1. But what you have to do is step 3, you take the note. You also do step 3 for, right? The table here I'm showing you is only for quarter 1. So what about for quarter 2? Now come to this table. Okay? Seasonal index for quarter 1, here we have 58, right? 58 for quarter 1 from step 1, and step 2 is 79.25. So we get 0.73, that is the seasonal index of quarter 1. So what about for quarter 2? Then 4-year quarterly average from step 1 is 90. Divided by step 2, we use the same number because that is the overall average. 90 divided by 79.25, then here. Quarter 3. Step 1, quarter 3 will be 92.3 divided by 70.25, the same number. And quarter 4, we do the same thing. So you see that now seasonal index column, that is the result from step number 3. Is that okay?
Yes.
All right. Now let's go to the last step. Step number 4, finding the deseasonalized sales data or seasonally adjusted sales data. Okay. To get step number 4, now I'm doing for you guys for 1 year, the whole year. Okay, the first year. If you want to get deseasonalized sales data, we have the actual sales right here. We have the actual sales data. That is the secondary data from your company. You have it already. So you look at year 1, quarter 1. Year 1, quarter 1, actual sales here is 49. We divide by seasonal index of quarter 1 because we are using the quarter 1 information. So quarter 1 actual sales by the seasonal index quarter 1. So this is the seasonally adjusted or deseasonalized sales data for quarter 1 only. So for quarter 2, what do we do? For quarter 2, now we look at the table. Year 1, quarter 2, 77. Remember that now we are focusing on quarter 2 information. Therefore, actual sales of quarter 2 is 77. We divide by seasonal index of quarter 2 because this is for quarter 2. So we come back here, 77 divided by the seasonal index of quarter 2. For quarter 3, and seasonal index for step number 3 is 1.16. So 90 divided by 1.16. So what about quarter 4? Year 1, quarter 4, actual sales 79, and we divide by the seasonal index of quarter 4. See that? So here, these are the deseasonalized sales data for year 1, quarter 1, 2, 3, and 4. Is that clear?
Yes.
All right. So in this example, I did for first year or 4 quarters. But what you have to do is, of course, you have to find out, right, for year 2. So for year 2, then what would you do? Year 2, quarter 1, you take 57 divided by seasonal index of quarter 1 will be 0.73. So you go through like this vertically. Okay? So now you look at this last column. The last column is from step number 4, deseasonalized sales data for year 1 only. But here we have year 2, 3, and 4. So 3 and year 4. And you repeat the step number 4, you can get the deseasonalized sales of the other quarters as well. Is that clear?
Yes.
Okay. I'm giving you about 2-3 minutes. Let's make it like 5 minutes. I'll give you 5 minutes. You look through these 4 steps. You look at the table, and you let me know if there is any question. Don't do it one by one, okay? You look through these 2 steps first, and you note down if there is any question. And you know when the time is like after 5 minutes. I'm giving you 5 minutes. Don't go anywhere, okay? Review it. Everyone in the group, please do that. Please review it, okay? 5 minutes. After that, we will go to the second part using different methods. Any part you have question, you note down, and then we will discuss about it at one time, okay? Assume that now you are working on your assignment, so you might have questions. Note it down.
Teacher,
Yes?
for I don't understand deseasonalized sales data.
What did I say just now? Where were you? I said that deseasonalized sales data means seasonally adjusted sales data. I said it already. I said both seasonally adjusted sales data or deseasonalized sales data. Is that what you mean?
Yes.
Is everyone okay with the step? Hello?
Yes.
Are you guys okay with the step?
Okay. Yes.
So, okay, listen. This is just the example. Therefore, we have 4 years, 4 quarters. You don't know what number I will give you, how many years I will give you, okay? In your company, also, when you really work, you don't know how many years data available and how the company will record the sales data. You guys don't know. So try to understand the way we do things, the way we think. Okay, so this is the first part. That is we call as finding the deseasonalized sales data. Okay. After that, what we will do will be second part. Based on the deseasonalized sales data, we will be estimating the future sales. So there are many different methods. Okay, we will do one by one. We will start with naive forecasting method. So I don't think I will tell you to take the screenshot because you have to do it. You have to take the screenshot every slide. All right. For naive forecasting method, managers assume that nothing will be changed. The current actual sales will be there, future sales, or current actual sales will be there, forecast for the next period. Listen again, okay? According to naive forecasting method, nothing is changing. Current actual sales will be considered as future sales. So that is the simplest method, easiest because we don't do any calculation. We just make the assumption that current actual sales will become the forecast for the next period. So now let's go to the example. 1, 2, 3, 4 as the example. Okay, so we will take only year 1, quarter 1, 2, 3, 4, just to do the example. Look at here, quarter 1, 2, 3, 4, and year 1 actual sales here. So these are the secondary data in the table. According to naive forecast, current actual sales will be the forecast for the next period. Based on that, if you look at actual sales of quarter 1, that will be the forecast for quarter 2. Actual sales of quarter 2 will be forecast for 3. Actual of 3 will be forecast for 4, and so on. So you keep doing that. You see that? So what about when we come to year 2, quarter 1? Year 2, quarter 1 is here. So that is going to be what? Year 1, quarter 4, actual sales 79 will be forecast for year 2, quarter 1. So we keep doing that. Then here, it is going to be like this, right? So what about here? Year 4, quarter 4. The actual sales forecast for what? Forecast for year 5, quarter 1. Where is it? Can you follow this? Do you understand?
Yes.
Yeah? Okay. This is according to night forecasting method. Think about it. Now let's look at quarter two. Quarter two, actual 77 and forecast 49. What is the difference between these two, actual and forecast? The difference would be like quite large, right? What about quarter three? Actual 90, forecast 77. So if you look at quarter two and quarter three, we forecasted or we estimated lower than the actual. So we might have out of stock, we might not have enough product, or we might lose the sales because actual will be higher than the forecast. We don't want that. So what about here, quarter four? Actual is, you see that? So if you look at this example, by using the actual sales to forecast the sales, there are errors that we make. So when we want to know the error, for example, quarter two, actual 77, but we estimated 49. We want to get the error, so we use this equation that is given in the textbook. We have the forecast, and we deduct actual sales divided by actual. Of course, this is the error in terms of percentage, so 35% and 36%. So you see that in quarter two, the forecast and actual, the error, forecasting error we make is 36%. That is three in quarter four. We also want to know how many percentage error we make. So when we come to this one, all right? Okay, take that screenshot. Done?
Yes.
Okay, you look. So just now from this slide, we calculated the forecasting error for quarter two. We cannot do it for quarter one because it was the very beginning of the operation. Okay, so now here when we come to quarter two, that is from the previous slide, what about quarter three and quarter four? So quarter three, forecast 77 minus actual, and quarter four, forecast minus actual. Okay, if you plug in the numbers, these are the percentage error. So we want to know that these are quarterly basis, the error that we make every quarter. So what about in the whole year? What is the overall mistake that we make in forecasting the sales? Overall, then we use this equation, MAPE, mean absolute percentage error. Mean, we are going to find the average of all these, okay? So we plug in the numbers in the equation. Actually, you know this sign, right? Summation. Forecast minus actual divided by actual. If you look at this one, okay, forecast minus actual divided by actual, that is this equation that we use already. So you may use this equation, plug in the number for quarter 2, 3, 4. You do it at the same time, or from here, for each quarter, we have the percentage error already. So we just plug in these percentages. We divide by 3 because 3 quarters. Okay? So overall MAPE, or overall mean absolute error within 1 year, year number 1. Here, year 1, overall forecasting error that we make is 20%. Right? The error is large. So what about for year 2, year 3, year 4? You do the same thing, right? So because of the error, which is very large, then we try to avoid the error. We want to reduce the error. So what we are going to do, instead of using actual sales in forecasting, we will use the deseasonalized sales that we found from the first part. Okay? So if you come to this one, you see, like, now pay attention. You guys don't ask anything. 49 minus 77 divided by 77. 40 time, right? Quarter 3 also, 77 minus 90, the answer is supposed to be minus sign. But we are calculating the error. Therefore, for the error, we take the absolute value. We ignore plus minus sign here. Is that clear? Guys?
Yes.
Okay, now, come back to this table. By using naive forecasting method, we are going to estimate that because of the errors that we found, we will not use the actual sales. So year 1, quarter 1 to 3, 4, these are the actual sales. We do not use them. To reduce the error, we will use these 4. These 4 are from here, step 4, from the first part. Okay, so now this is a little bit confusing. Try to pay attention and then listen, try to understand, okay? Take that screenshot. Are you done?
Yes.
Okay. You pay attention to the ones that I highlight, all right? So it's going to be easier for you guys. According to naive forecast, current actual sales will be forecast for the next period. We're still using year 1, quarter 1 to 3, 4. Year 1, quarter 1 to 3, 4 with the actual sales, okay? But just now we found like large error. So instead of using actual sales here, we will be using the decentralized sales. In this table, decentralized sales for year 1. Quarter 1 is 57. Year 1, quarter 2, 68. Quarter 3, 78. And quarter 4, 81. So we do not use these. We will use the last column here. So come back here. 67, 68, 78, and 81. These are the decentralized sales data. Can you follow up to now?
Yes. Yes.
The question is, why don't we use actual sales data? Why do we have to use decentralized sales data? Think about it. Now, come back to this table. I'm telling you the reason, okay, why decentralized sales. When we come to this table, you see, these are the actual sales data. Assume that now we are in year 2021, almost end of the year, okay? So in this case, then, if we are going to forecast for year number 5, which is year 2022. Year 2022, so here year number 4 will be 2021. Year 3, 2020, 2019, and 2018. In terms of number of years, only 4 years. But in terms of quarter, how many quarters? 16 quarters. Assume that now this is what? This is end of quarter 3, we are going to be about quarter 4. Assume that if we were in quarter 4, and we are going to forecast for the next period, and we are using the past data. Think about it. Year 4, quarter 4 right now, and 4 years ago, year 1, quarter 1, 16 period, it was so long already. You see that? In this case, then, because of the changes in the market, changes in the, fluctuations in the market, okay, we have to be careful that we need to deal with those changes and how we are going to make the adjustment. But we have to be careful, especially for seasonally fluctuation or seasonal products. Okay, for seasonal products, the demand will be changing. There will be a lot of fluctuation. In this case, then we cannot always assume that like the actual sales will be like useful until like next year, 2 years ago, next 2-3 years, or like according to the quarter. Okay, we cannot rely on actual sales 49. That was like 16 years back, and we are considering it in part of our forecasting. So after 16 years period, then there will be changes, right? And we can, because of this kind of situation, since the longer period that we consider in the past or the previous sales, we need to adjust those past actual sales data to fit in the current situation. That's why we need to use decentralized sales data. Decentralized sales data or seasonally adjusted sales data. Seasonally adjusted sales data, those actual sales data, we adjusted seasonally already. Remember, for Q1, we consider the seasonal index of Q1. For Q2, we consider seasonal index of Q2 and so on, right? So in this view, which are seasonally adjusted already, we will be able to get better forecasting numbers. Is that clear? See that? So did I answer your question completely now? Hello?
Yes.
Did I answer your question completely now?
Yes.
The decentralized sales data.
Yes.
We adjusted previous actual sales data to fit in the current situation in forecasting. So we adjusted, okay? We adjusted it. Now, look at the table. So here, these are the actual sales, seasonally adjusted sales. We have them already here from step number 4. When we forecast the sales, according to naive, current sales will be the forecast for the next period. So when we use deseasonalized sales data 67, according to naive, Q1 deseasonalized 67, so forecast for Q2 will be 67. But why 76 here, right? Also, here Q2 with 68, but when we forecast, becoming 79. Because we need to adjust back to fit in each quarter. Deseasonalized sales, that is for Q1. In step number 4, we consider just for Q1, so we divide by seasonal index of Q1. We adjusted that actual sales data to be deseasonalized sales data, but using Q1 information. Now we are going to forecast. We need to adjust it back. Deseasonalized sales of Q1, we will multiply back by seasonal index of Q2. So that sales data will be the sales forecast for Q2 that we are forecasting here. Can you follow?
Could you repeat it again?
Instead of using actual sales 49, to deal with those seasonal changes and fluctuations in a long period of time that we consider, we are using deseasonalized. But that is seasonally adjusted only for quarter one. We are going to forecast for quarter two. Therefore, that seasonally adjusted sales quarter one, we have to adjust it back to fit in quarter two. Step number 4, for quarter one, deseasonalized sales, we divide by seasonal index of quarter one because this is for quarter one. Now, we are going to forecast for quarter two. Therefore, deseasonalized index for deseasonalized sales of quarter one, we have to adjust it by multiplying with seasonal index of quarter two so that will be fit in for quarter two. Is that clear?
Yeah.
You continue looking at the other two, you get more idea, okay? So what about for quarter three? We have deseasonalized sales of quarter two. We are going to forecast for quarter three. 68 will not become 68 directly. 68 is in step 2. This is for quarter two. So we get deseasonal sales of quarter two. Now we are going to forecast for quarter three. Therefore, we adjust it back by multiply with quarter three seasonal index. So this is for quarter three. So quarter four, the same thing. Quarter four with deseasonalized sales 81, that is from step number 4. But in step number 4, quarter 4, we are using the seasonal index of quarter 4. And we get the seasonally adjusted sales for quarter 4. Now we are going to year to quarter 1, right? If you come to here, quarter 4, year 1, quarter 4, then we are going to estimate for year 2, quarter 1, this one, isn't it? So year to quarter 1, then what is the seasonal index? 0.73. That's why here you will multiply by 0.73. What happened? What is going on? I cannot copy. Oh, what did I do? Is that okay, guys? Why everyone is quiet? Is that okay?
Yeah.
Okay, I'll give you some time. Let me do this one first. Let me do this, and then I'll give you time to review, okay? So now when we get the forecast, okay, by using naive forecasting method, the error, forecasting error, forecast minus actual divided by actual multiplied by 100%. So forecast from naive will be 76 here, and actual 77 divided by 77. So for quarter 2, the error we make here is only 1.3%. So you see, like from the first example, using actual sales, the error was 36%. But now, after using decentralized sales data, then the error is only 1.3%. So you see that by using the decentralized sales data, then we can reduce a lot of errors. So if you want to forecast 79 divided by actual 90 divided by 90, right? So percentage error for quarter 4, then 76 minus 79 divided by 79. So you can reduce the error a lot. See that by using decentralized sales data. That's why it is suggesting that instead of using actual sales data with many long periods of time, we should use the seasonally adjusted sales data or decentralized sales data that will help us reducing the forecasting error. I'll give you about 3-4 minutes, guys. About 3-4 minutes, look at the whole slide, and then you let me know if there is any question. If you are not sure, you can use the calculators, okay? Press the calculator, try to get the number. So if you remember this one, you see, like if you want to get the forecast, you have the seasonalized sales of current multiplied by seasonal index of the next period. Because forecast is supposed to be FT plus 1, right? If you want FT plus 1, then the seasonalized T multiplied by SIT plus 1, okay? Questions, guys? Any questions? Any questions? Okay, no response. So I assume that everyone is clear with what you are saying. Let's go to second method. Second method of forecasting would be moving averages. Okay, just now we saw that according to naive approach, we just make the assumption that current actual sales will be the future forecast, future sales. So as I said just now, okay, that there are fluctuations, and especially for seasonal products, we cannot always assume that current sales will be the future sales, right? In this case, then what we will do will be, we can use another method, that is moving averages. So when we use moving averages, we are going to find the average of the past sales will become the forecast. So how many periods average, okay, that depends on how much sales data you have. So now for moving averages, this is a formula that we have to follow, okay? FT plus 1, future T plus 1 for the next period. We have to consider the actual sales of current, actual sales of last period, actual sales of 2 periods ago, and so on. And here, how many periods we will be using, considering in the calculation, okay? So based on that, then now we will be using the same table. The same table, we will be using the same numbers like year 1, okay, for averages. Year 1, quarter 1, 2, 3, and 4, and we have the actual sales. You see that given already. So according to this example, we are using 2 period moving averages. Therefore, 2 periods, we are going to use period 1 and period 2. So we will be able to estimate for period number 3, right? Since we find the average, we need at least 2 data, isn't it? So FT plus 1 will be F3. F3, then ST. ST is supposed to be 77 plus ST minus 1, that is 49 here. 2 quarters. Then this is the average, that is the forecast for quarter 3. So what about for quarter 4? Then we will be using quarter 2 and quarter 3 information. Okay? For quarter 4, FT plus 1 is F4. F4, ST 90 plus ST minus 177 divided by 2. So this is the average, and that is the forecast for quarter 4. Okay, so what about for when we come back to the table here again? After quarter 4, the next period that we will have to estimate will be year 2, quarter 1, right? So year 2, quarter 1, then in this case, come to here. Year 2, quarter 1, we have 79 plus 90 divided by 2. So the average 84.5 would be the forecast for year 2, quarter 1. Is that clear?
Can you say again?
Which one?
The last one you said.
After you find the forecast for year 1, quarter 4, year 2, quarter 1, right? So for year 2, quarter 1, 2 period moving averages. So year 2, quarter 1, that is going to be period number 5, because we count like 1, 2, 3, 4. So this is 5, 6, 7, 8, right? So period number 5 or year 2, quarter 1. To get forecast for this one, then you have 79 plus 90 divided by 2, and that average will become the forecast for year 2, quarter 1. These two divide by 2, and you get this one.
Okay.
Okay?
Okay. Thank you.
All right. Anybody else? Question? Oh, come on. This is very simple using actual sales. Now, let me show you something else. Take the screenshot. Done? Are you done with it?
Yes.
Okay. Before we come to this example, let me tell you one thing. Look at this table. Quarter 1, 2, 3, 4. We have 4 years. We have 4 quarters. 4 multiplied by 4. We have total 16 sales data. We can call these 16 data as year 1, quarter 1, year 1, quarter 2, year 3, quarter 4, year 4, quarter 3, year 4, quarter 2, and so on for each like year and quarter. Or if we count year 1, quarter 1 as number 1. So year 1, quarter 2, number 2, year 1, quarter 3, 4, year 1, quarter 4 is number 4 in terms of period, because we are using 16 period sales data. Period 1, 2, 3. So when we count quarter 1, year 2, quarter 1 will be equivalent to period number 5, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Year 4, quarter 4 will be equivalent to period number 16. You know that, right? You know that, isn't it? 1, 2, 3, 4. We count. If you study accounting,
Yes.
definitely you know it. Okay, now let's come to this one. By using actual sales, we can make a lot of forecasting errors. Even in moving averages, we try to use seasonally adjusted or you look according to what I highlight, okay? These are the time periods. Time periods 1, 2, 3, 4. That is year 1. Year 1, quarter 1, quarter 2, quarter 3, and quarter 4. So after year 1, quarter 4, number 5 is supposed to be what? Number 5 is supposed to be year 2, quarter 1. Number 6 is supposed to be year 2, quarter 2. And so on, we keep counting. So period number 16, as I said just now, period number 16 is equivalent to year 4, quarter 4. So there are total 16 periods. Can you follow?
Yes.
These 16 in the table, we don't write them like in table. We write them like number 1 until like we spread out. We spread out, becoming like 16 here. Okay? Actual sales are given, but we don't use the actual sales now. We will be using seasonally adjusted sales. When we use seasonally adjusted sales, so quarter 1, 2, 3, 4, seasonally adjusted or deseasonalized sales data, they are here already in the last column I did for you guys, right? here. So what about year 2, year 3, year 4? I told you that step 4 you have to do for the other 3 years, right? So you will get like 16 deseasonalized sales data already if you do step number 4, year 1, 2, 3, 4. So those 16, that means that this column is, I did it for you. For you guys, you have to add 3 more columns, year 2, year 3, and year 4. And you repeat step number 4, so you have like here, decentralized sales data already. So starting from 67, okay, until like year 4, quarter 4, so you will be getting the deseasonalized sales data here until period number 16. From step number 4, I did Can you follow? So you also can get this number by following step number 4 until year 4, quarter 4. Is that clear?
Yes.
Now let's see using 2-period moving averages. When we use 2-period moving averages, we are going to use the seasonally adjusted sales data or deseasonalized sales data. 2 periods we divide by 2. Okay, so look at this one. According to the equation FT plus by N, FT F3 for period number 3. So ST will be period number 2, S2 plus ST minus 1 will be S1. F3, so here. But now you see something here. We multiply by seasonal index, right? Because you see, like just now when we did naive forecast, deseasonalized sales data is for that particular period seasonally adjusted sales data. But we are estimating for the next period, therefore we have to multiply back by the seasonal index of the next period. So if you look at here, we have the deseasonalized sales of period 1 and period 2. 2 periods, therefore we divide by 2. But we are forecasting for period number 3. Therefore, we multiply by seasonal index of quarter 3. So seasonal index of quarter 3, if you forget, come back to table. Here. Okay? So this is the forecast for period number 3 by using seasonally adjusted or deseasonalized data. Which is Is that clear, guys? Student?
Yes.
So what about F4? F4. F4 is supposed to be then period number 4. So we will be using these two numbers. We divide by 2, multiply by seasonal index of quarter 4, right? So seasonal index of quarter 4 is supposed to be 0.97. So we get 70.1. So this is only for 2-period moving averages. So what about one more? Don't cry. 3-period moving averages. We just add one more period, that's it. When we add one more period, then seasonal index multiplied by seasonal index of that future period. The same thing here. We just add one more period. Okay? For 3 period moving averages, since we are using 3 periods, 1, 2, we'll estimate for period number 4. For period number 4, S4. So S1, S2, S3, 3 periods, therefore we divide by 3. And we are forecasting for period number 4, therefore multiply by seasonal index of quarter 4. So seasonal index of quarter 4, if you forget, come back to the table, that is 0.97 here. Is that okay? Student?
Yes. Yes.
Okay, you take the screenshot of this one. Additional example, okay? When we use moving averages and when we use decentralized sales data, we multiply by seasonal index of So just now we saw already that 2 period moving averages for period number 3 multiplied by seasonal index of quarter 3. So when we want to estimate for period number 4, then we multiply by seasonal index of quarter 4. This is 2 period moving averages. So when we come to period number 5, here, period number 5, to estimate period number 5, if we're still using 2 period moving averages, that is supposed to be 78 and 81, right? 78, 81, we divide by 2, but we multiply by seasonal index of one year. We have only 4 quarters, quarter 1, 2, 3, 4. Period number 5 is equivalent to year 2, quarter 1. We do not have quarter 5. Don't say that quarter 5. You get 0 for that if you say quarter 5, okay? Period number 5 is equivalent to year 2, quarter 1. Therefore, if you estimate or forecast for period number 5, then you use the decentralized sales of period 3 and 4 of year 1, but you multiply by seasonal index of year 1, seasonal index of quarter 1. Here. Period number 5. The same here for period number 5. You will be using these 3 sales data, okay, seasonally adjusted or deseasonalized sales data. We divide by 3, right? But since this is period number 5, equivalent to year 2, quarter 1, then we multiply by seasonal index of quarter 1. Is that clear?
Yes.
All right. So we still have one more example under trend forecasting, okay? We will do it in the next class. But for your assignment, we will be focusing on either naive or moving averages, okay? Let me figure out. All right. We have only 1 minute left. What I want you to do is you guys you review all the steps, okay? And try to understand how we do, how we think, okay? So probably this weekend, I might give you the, how to call, like the assignment, okay? You might have about 2 weeks to do the assignment. Okay, guys?
Okay. Okay.
All right. So before you guys leave, can you guys type in your names, IDs in the chat box, and we'll see again next month.